Okay, Mr. Hunt here with angle constructions. I'm going to do number one, construct a copy of the given angle, or in other words, make a congruent angle. So what I'm going to, we actually did this one previously in 5A, making an angle copy method for a parallel line. So it's actually the same one, but it looks a little different. So I'm going to just draw a straight line. First I need a line that represents the bottom of my angle, so down here. So I'm just going to draw a line with my straight edge. It doesn't have to be very long, but I just made it longer than this one. So that represents the bottom part of my angle. Now to get this, I just need this side of my angle. I'm going to do what I did in that angle copy method. So I'm going to make an arc. So I'm going to put my compass on, I'll say, point A, and make any arc you want, any length. Okay, so I made that one. Then I come over here to this, well, really either endpoint, doesn't matter, but I'll just go to this endpoint, and I'll make that same arc. Make sure it looks like the other one. Make sure you didn't do it just up to like here, because then it wouldn't go far enough. Okay, and then there's only one more thing. You need to know where to draw on this line, so you need another marker somewhere around here, and we know the distance where the arc intersected the angle. So you get this on your compass, this length. So put my compass down here, set it to this length, make a mark like that to show me that you did it, and then come over here and do the same thing. Okay, and then I just connect these two points. And there we go. I copied that angle. I made a congruent angle. Again, I'm going to move on quickly, but pause the video if you want to look back. Number two, construct an angle bisector. This is an important one. It's similar to the perpendicular bisector method. It's going to look fairly similar. Adjust that. There we go. Angle bisector. Okay, so we want to split this angle into two congruent angles. I'm going to make an arc. Alright, so I'm going to... I could have adjusted this a different size, but I just kept it that length. Okay, so what I have now, the key thing that did is it made 2 points here and here, I'll call them A and B, that are equidistant from our vertex. I'll call that C. Okay, so it made equidistant. This might look like the rhombus method for making a parallel line. It actually is the same thing. Okay, so then what you're going to do is from B and A, you need something out here so that you know where to draw on this line. And since A and B are equidistant from C, you can now start at B and make, again, always full circles would work, but I'm just going to make these arcs out in the middle. Okay, that are equidistant from B. I'm going to turn this, I do the same thing, equidistant from A. Oh, and by the way, I could have adjusted this before, but once I go from B and A, I need to be the same length. I can't move my compass length from B and then change it on A. Okay, and if you remember, if we were doing the rhombus method, I just draw this in right here, make a parallel line. But I'm doing a angle bisector, so I connect this new point with C. There we go, and I cut my angle into two congruent angles. This method, by the way, you'll remember, it works because for a rhombus has diagonals. This represents the diagonal of a rhombus here, if I would draw it in. And they have they have angle bisectors as diagonals. The diagonals cut these angles in half. So that's why it works. Okay, I'm going to move on to 4. We'll end up doing 3 by doing